Right, welcome to this month's glove update, this time in video form because pictures won't do the problem solving I've had to do justice over the last few weeks. So to get to the point, with the way the current glove design works, people are expected to space a sensor and a magnet apart at a fixed length relative to the length of their own skeletal structure. This is so that the sensors actually sit at the right point relative to the joint, and so the overall force feedback mechanism actually has something to push back against. Because right now, if you didn't have a solid frame, whenever you pull back on the string, the motor would essentially have nothing to push or pull against, so you wouldn't get any force feedback, which makes these connecting sensors or these connecting modules very important for the overall structure and rigidity of the glove, because not only do they carry the force feedback line, they also act as the wire channels that carries the sensor data and the haptic motor power through the splay board and actually to the main glove, or to the main glove board rather. And this is fine and good and all, but because of the way cables work, and because each hand is unique, right now the user has had to measure their fingers and get me those numbers so I can figure out which length cable is best suited for this app or for that particular finger. And that is a ball ache, not only for me, but for literally anybody who's going to have to put these together. And if I'm designing something that's meant to be used as a product, as much as I hate that word, then it needs to be as brain dead to use as possible. So if I can eliminate the need for users to measure their fingers and ultimately eliminate the need for those peculiar lengths of cable, then we're on to a winner. So I've spent, like I said in a few other posts, I've spent the last few months optimizing the design to make it much more user-friendly. And over the last few weeks this month, most of the problem solving has gone into these bad boys. You might be able to see some similarities, mostly because it is largely the same design, except instead of a dedicated wire channel, the electrical contacts are now embedded into the module segments. Haven't even done anything that magical. So far, I'm experimenting with paper clips that are just bent into shape. It's proven to be much more reliable than I expected. Ultimately, if this design does make it to the final design, we'd be using a metal that's purpose-made for electrical conductivity, probably like some kind of phosphor-plated brass or whatever it is they use in the like tenth of an inch headers that you'd find on stuff like Raspberry Pis or things like that. So the main reason why this is so magical is because embedding the electrical contacts means no more measuring fingers. And no more measuring fingers means no more wires. And because there's no more wires, users are going to have a much easier time putting the gloves together, because if they order a set of parts and a set of wires that are the wrong length, then if it's too long, it's not much of an issue, but if they're too short, you're out of luck. Whereas embedding the conducts or conductors into these segments essentially turns them into the cable. So instead of having to measure the wire, put the glove together, realize it doesn't work, hit up me or whoever it is they're getting their parts from and say, hey, I need new cables. Instead, they can go back to their box of parts, because the idea is this will eventually be produced somewhat like a Lego set, where you'll get just a bag of bits that you can put things together. they'll be able to get the different length variants of these guys and just fiddle for as long as they need to, getting things as long or as short as they possibly can go. And these do come with measurements on them. 5mm being the shortest and 9mm being the longest. I mean, that's been the standard lengths. 5, 6, 7, 8 and 9mm lengths have been the standard lengths for the module segment so far. The idea being that if you need a 10mm one, you can just stack 2 5s. If you need an 11mm one, you stack a 5 and a 6. If you need 18mm, you just stack 2 9s. So it's essentially just basic maths. But yeah, as I've been saying, the idea is that embedding the contacts here means the overall UX is a lot more simplified. This is starting to feel pretty waffly, and I'm not entirely sure how I'm going to end this video, so I'm going to call it here. When it comes to... Actually, I lie. When it comes to the PCB design reworks, those are still ongoing. In fact, they've kind of slowed down, because while I'm reworking the electrical contacts in these, it means reworking the contacts in the sensors. It means adding contacts to the magnet holders. It means reworking the connections in the splay boards. It means redoing the electrical contacts for the haptic add-ons, and finding a way to actually embed contacts into the... I haven't actually got a name for this piece yet. The finger bracket, I guess? The finger segment? But yeah. So essentially, because of how ingrained or how in-depth this change is, it does effectively mean that I have a fantastic excuse to go from the V7 to the V8.